first part is going to be about conditional statements. So conditional statements have two parts. We have an if and then a then part. It's basically a cause and effect relationship. If this happens, then this will happen. If an animal is a spider, then it has 8 legs. The hypothesis is the part that comes after the word if. The conclusion is the part that comes after the word then. So we have those two parts, the hypothesis and the conclusion. We're going to circle the hypothesis and underline the conclusion. If an animal is a reptile, then it's cold-blooded. Doesn't need to be in this order. 4 angles are formed if 2 lines intersect. If 2 lines intersect, 4 angles are formed. Typically, you see the if part first, then the then part, but it doesn't actually have to be in that order. If you see if, that is the hypothesis, and the other clause is the conclusion. We're going to rewrite these conditional statements. Rewrite the conditional statements in if-then form. All cats have a tail. If it's a cat, it's a cat, then it has a tail. I guess you could also say it differently. If an animal is a cat, then it has a tail. But as simple as you can write it, that's the way I'm going to write it. Full cartons have 12 eggs. So if a carton is full, then it has 12 eggs. Conditional statement is just the if-then statement. Then there are these 4 words that are related to that conditional statement: converse, inverse, contrapositive, and biconditional. We use the letters P and Q to represent the hypothesis and the conclusion. P represents the hypothesis. Q always represents the conclusion. So if an animal is a dolphin, then it's a mammal. That's our original conditional statement. That one's true. If an animal is a dolphin, then it's a mammal. The converse of that statement means we switch the hypothesis and the conclusion. We're going to say if Q, then P. We switch the order. The conclusion and the hypothesis switch spots. So we're going to rewrite this example. If it's a mammal, then it's a dolphin. That's not true. Dogs are mammals, they're not dolphins. So this is important, that the conditional statement, it actually could be true or false, but these don't have the same logical equivalency. If this is true, this does not have to be true. The converse doesn't always go with the conditional statement. They're not linked together in their validity. The inverse means we keep the order the same, but we negate the hypothesis and the conclusion. That basically says, if not P, then not Q. So negate means changing it to a negative, or if it's already a negative, you could change it back to a positive. Keeping the order the same, if it's a dolphin, if it's not a dolphin, then it's not a mammal. The same counterexample works. A dog is not a dolphin, but it is a mammal. That's false. The contrapositive mixes these two together. We change the order, and we negate both. So if not Q, then not P. So we change the order. Q comes first, then P, and we negate both of them. So if it's not a mammal, then it's not a dolphin. That is true. If it's not a mammal, couldn't possibly be a dolphin. This is always the case. These are logical equivalents of each other. These two statements are essentially, are essentially saying the exact same thing in a different way. The exact same thing is true of the converse and the inverse. They're actually contrapositives of each other. These two statements are logically linked. If one of them is true, the other one has to be true. Same thing with the conditional statement and the contrapositive. If one is true, the other one has to be true. A biconditional means that all four of these were true. So this is not going to be true in this case, but if all four of these statements are true, then the biconditional statement is also true. Biconditional is basically saying if one of these is true, the other one is also true every single time. So we say P, if and only if, actually sorry, let me write it out the first time. I'm going to abbreviate that as IFF, but I'm going to write it out the first time. P, if and only if Q. We abbreviate that as IFF. So, an animal is a dolphin if and only if it's a mammal. So this one doesn't start with an if statement. It's not if then. You just start the statement. An animal is a dolphin if and only if it's a mammal. This is false. An animal, I like breaking this into two sentences. An animal is a dolphin if it's a mammal. Already by itself, that's not true. An animal is not a dolphin if it's a mammal, because there's other types of mammals. The second part of this is true, so sometimes it just gets tricky if you read this in just one sentence. An animal is a dolphin only if it's a mammal. That part of this statement is true. It has to be a mammal for it to be a dolphin. But overall, that statement is false because not all mammals are dolphins. We could have told that before just reading this part. If any part of this is false, if any of these four are false, then the biconditional can't be true. All right. We're going to just practice a little bit with this and then think about how we write a counterexample. A counterexample, what we talked about here, would have been a dog, because a dog is a mammal, but it's not a dolphin. It's an example that makes the statement false. All right, so our conditional statement, if the measure of angle A, I just want to make sure that you're familiar with that notation, the measure of angle A is 95 degrees, then angle A is obtuse. That statement is true. That is called an obtuse angle because it's greater than 90. The converse is switching the order. If angle A is obtuse, then it has a measure of 95 degrees. That is false. There's other obtuse angles. Counterexample would say that the measure of angle A is 93 degrees. That's an obtuse angle, but it's not 95 degrees. The inverse means we're negating both of them. If the measure of angle A does not equal 95, then it is not obtuse. That is false again with the exact same counterexample. If A equals 93, that's true. It doesn't equal 95, but that's still obtuse, so that part's not true. Contrapositive means we're flipping it and negating both parts. If angle A is not obtuse, then it is not, then the measure of angle A, sorry, I just said that wrong. The measure of angle A is not 95 degrees. That is true. If it's not obtuse, it can't be 95 degrees because that's an obtuse angle. That one is true. So again, you see that these are logically equivalent. If one's true, the other's true. Same thing here. These two are logically linked together. If one's true, the other one has to be true. So the biconditional would be that angle A is obtuse if and only if the measure of angle A equals 95 degrees. That is false. Same counterexample works. The measure of angle A could be 93 degrees, which means that that can't possibly be a true statement. Angle A is obtuse if and only if the measure of angle A is 95 degrees. Well, that can't be true because it could be 93. All right, last thing, just about notation. Abbreviating this with if Q, then P. It's definitely nicer than having to write the whole thing out, but we have an even shorter notation. This is another way to represent an if-then statement. An arrow shows that whole thing just with one symbol. If P, then Q. If Q, then P. We also have that notation that I showed before, not something. So we had the apostrophe when we were dealing with Venn diagrams, but when we're dealing with logical statements, we're going to use this symbol to mean not. So we could say if not P, then not Q. Or for the contrapositive, we're flipping and negating. So if not Q, then not P. Or just a notation, not P leads us to not Q, and not Q leads us to not P. Biconditional is a two-way arrow. So the simplest way to write this, P if and only if Q, or with notation, it's not even that much shorter, but that is a two-way arrow saying that P leads us to Q and Q leads us right back to P. It's basically a definition. Those have to be completely the same statement for this to be true. Right, the real importance of this is because computers talk this way. I mean, it's also important to understand a cause and effect relationship. If something happens, then something else happens. It's just a trigger for the second thing to happen. That's an important understanding. But it's really how computers, it's how electrical engineering, there's a lot of different applications of this conditional statement logic. If something happens, if that question is answered with true, then this happens. If it's answered with false, then something else happens. That's exactly how computers think. You get an input, and there's some output based off of that feedback. So if you're doing anything related to computer science in any way later in life, you're going to be wrapped up in conditional statements. Hope this helps, but if you need any more help, ask some questions.